Okay, looking at cubic graphs now, and cubic equations. It's exercise 1F in our textbook. So just a bit of background on cubics. They're polynomials of degree 3, so excuse me, the highest power of x in these equations is x to the power of 3. So general form there, y equals ax cubed plus bx squared plus cx plus d. We can define cubics as being positive cubics or negative cubics. It's all really got to do with the sign, sign, out the front of the x cubed term. So if that was a positive number like 2x cubed or 10x cubed, etc., so positive number out the front of the x cubed, it's what's called a positive cubic. So that is if a is greater than 0. And typically, these sort of graphs start top right, so up here, and finish bottom left, down here. And they have what's called a maximum there, and a minimum there. Okay, maximum and minimum. And later this week, I'll show you how to calculate maxima and minima using our graphics calculator. And we'll do a bit more of that work when we do calculus later, differential calculus later in the year. But for the moment, that's a positive cubic, top right, bottom left, maximum, minimum. A negative cubic is the opposite, and here our value of a, that is the number in front of the x cubed there, would be a negative number. So a negative 3x cubed graph, etc., would be of this type. So it starts bottom right this time, so down here, and it finishes up here at, not finish, it keeps on going, but the end of the graph on paper ends up there at top left. So bottom right to top left, that's the general shape of a negative cubic. Now, cubics can also be in what's called power form. Okay, so we've got general form with a maximum, minimum, positive or negative cubic, but they can also be in power form. And this is similar to the work we did on quadratics, where you take a general shape of x cubed here, which is like so. You might have seen this before. Okay, and we know that point there is called the point of inflection. Okay, so inflection point. Okay, now I never draw this very well, but if you look in your textbook, you can see that at that moment, at that point, the graph actually has a gradient, flattens out horizontally, actually has a gradient there of 0. Okay, so at that point there, m equals 0 at b comma c. Okay, so that's the point of inflection. So similar to what the translations we did with the quadratic graphs. Okay, these graphs can be shifted to the right, they can be dilated, more on that in chapter 2, and they could also be shifted up and down. Okay, so a positive number in the brackets there, so an x plus 3 would take it to the left 3 places, opposite thinking, remember, and a negative 3 there takes it to the right 3 places. A positive c takes it up, a negative c takes it down. Okay, so that's the general form. And this form here, so once again, we've got top right to bottom left situation. Top right to bottom left. That's a scenario where a, the number in front of the bracket there, coefficient of the bracket, is greater than 0. Conversely to that, you've got a situation where it's in that form where it's a is a negative number. A is less than 0. It goes top left down there to bottom right. And once again, the point of inflection is in there this time. So, just recapping. Okay, you've got positive cubics there, and they can be in factor form, as we'll see in a moment. A negative cubic, if they're in power form, it's the positive version, a is greater than 0, and that's a is less than 0, a negative number. Sometimes we can say these things are in factor form, and if they're factorized nicely like this, a outside of x minus b, x minus c, x minus d, we can get nice intercepts here, b, c and d. where the graph crosses the axis. And I'll do a practical example of that in just a moment. Once again, in this case, A is greater than 0 because we've got top right to bottom left scenario. We get repeated factors, and you'll notice here we've got x minus a squared. And in this case, most intercepts where there's no power associated with the bracket, let's go back for a moment. Here, with each of those brackets here, x minus b, x minus c, x minus d, there was no power associated with those brackets. So the graph passed through those points. When you've got a power associated with the brackets, like here, you've got x minus a squared, that would mean that at A, the graph bounces or reflects off that point. So it also becomes a turning point, in this case a maximum. Okay, so that's repeated factor. If you've got a squared associated with the bracket, at that intercept, the graph bounces off the axis. Alright, first question now is this one. And this is an example I got straight from the book. And in the background it says, okay, find the graph. So we're going to find this graph. And we've got to assume, it tells us, just for the moment, that A equals 1 or negative 1. So that's the first decision we make. Is A 1 or is A negative 1? Well, this has all got to do with, back to the first slide, okay, about positive cubics, and if our overall dominant power there, dominant sign, it's often called the dominant term, is A is greater than 0, then it's a top right to bottom left graph. So we look at this graph that we're trying to find the equation for. It's a top right to bottom left graph. So our value of A will be 1. We can make that decision already. Okay, so it's going to be y equals 1, A is 1, and then we've got our three brackets. Now our intercepts are 0, 3 and negative 4. Now if one of our intercepts is 0 in these cubics, then outside our two brackets we're going to get x. So there's going to be an x term there. Okay, I've talked in class the other day about going the other way. If you're trying to graph something with an x outside the brackets, you know it's going to pass through the origin. Okay, we've got a plus 3 there. Now that equates to a bracket which is x minus 3. We've got a minus 4 there. That equates over here to a bracket of x plus 4, opposite signs. Okay, so our equation here, now we don't write 1x, alright, it's just going to be x, so it's y equals x outside of x minus 3, x plus 4. So there we are, there's the equation for that graph. Once again, assuming of course that A is 1 or negative 1. Same thing again, this time we've got that opposite pattern. We've got bottom left to top right. So this time A is going to equal negative 1. Okay, it's a negative cubic this time. Also got a negative 2 here. A negative 2 here, where we've got a reflection point. So y equals negative 1. Okay, we've also got a intercept here at 3, so the bracket that's going to equate to is x minus 3, and we've got over here negative 2, which equates to x plus 2 in the brackets, and because it's bouncing off, it's squared. Okay, it reflects off. So we've got negative 1 outside of x minus 3, x plus 2 squared. Now with this one, you can actually incorporate the negative into this bracket here, and it's probably what you should do in fact. So if I multiply that first bracket by negative 1, I actually get 3 minus x. Negative 1 times negative 3 is 3, negative 1 times x is negative x. And it's better to put the bracket as 3 minus x rather than negative x plus 3. Okay, that's not how it really should be written. So that makes that first bracket 3 minus x. Does it change the second bracket? No, it doesn't. It just stays as x plus 2 squared. So there's our equation for the graph that was presented there. Alright, sketch the graph of y equals x cubed minus x squared minus 10x minus 8, showing all intercepts. Note that at the moment we're not finding turning points. We'll do that when we get to differential calculus. Alright, so good thing about this question, it incorporates a lot of the stuff we've done so far this year. So, graphing to find y-intercepts make x equals 0, to find x-intercepts make y equals 0. We're going to have to do some factorizing and some other things here. So let's start off by finding the easy one. The y-intercept, we make x equals 0. So let's do that. Y equals 0 cubed minus 0 squared minus 10 times 0 minus 8. Oops, don't need that bracket. And obviously that's going to mean that the y-intercept, because 0 is everywhere there except to here, which we've got -8, will be 0, -8. Now, of course, we all know now the shortcut there is that when you get the y-intercept, okay, it's just going to be the number out by itself there, which is -8, because all those others, when you multiply, or when you substitute x equals 0, are going to disappear there. Alright, now, to find the x-intercepts, we make y equals 0. So, we're going to get 0 equals x cubed minus x squared minus 10x minus 10x minus 8. Okay. Now, to work this out, we haven't got our calculator. We're going to have to factorize this expression. Okay, x cubed minus x squared minus 10x minus 8. Right, to factorize this, remember, we've got to go through the process. I'm going to go straight to a successful one to save a bit of time here. We have to find numbers that will go into this expression that will give us 0. Because remember the factor theorem, if p of -1 equals 0 here, then we've got ourselves a factor. And as I said, I'm cheating a bit because I'm going straight to the correct one, the one that's going to work, but you might have to do a bit of trial and error here. So equals, that's going to be -1. -1 squared is 1, so negative of that is -1 again. -10 times -1 is plus 10, minus 8, so that equals 0. Therefore, x plus 1 is a factor. Alright, so what we can do now is, now that we've found x plus 1 as a factor, we've got our choice now between synthetic or long division, and x plus 1 is a factor, so at the side of our grid we're going to do synthetic division, is -1. Our coefficients go up here. So as I said, a good part of this question, we're revising a lot of the skills that we've done already. Okay, there's our coefficients. We've got our -1 at the side because x plus 1 is a factor. We put the opposite sign. So bring down the 1, multiply, -1 times 1 is -1, add, -1 is -2, multiply these two guys here, -1 times -2 is 2, add, we get -8, -1 times -8 is 8, add, we get 0. As we should do if we've done it properly. Alright, so our first factor, remember, was x plus 1. When we divide x plus 1 into that polynomial, we get x squared, 1x squared, minus 2x, minus 8. Then we need to factorize that. We get x plus 1, and we get x minus 4, x plus 2. Now we can return to the question, because the reason we had to do that, we had to find the values for x when y equals 0. So we now equate that to 0, and we can now find our 3 x-intercepts. Okay, so x-intercepts are going to be -1, 0, 4, 0, and neg 2 comma 0. And remembering our y-intercept was negative 8. Zero comma negative 8. Just go back to the original slide. Now our value of a, that is the number in front of the x cubed. So here a equals 1. So it's going to be a positive cubic. It's going to start top right to bottom left. That's going to be our general shape. Because the sign in front of the x cubed term is positive, it's a 1, that's how it's going to be. Alright, so we can now draw this graph. Now bear in mind, so we'll just put here a is greater than 1. Bear in mind that we don't know the turning points at this stage. We're going to do that when we do differential calculus, and you would have done some work on that last year. So we won't be able to draw without a calculator an extremely accurate graph here, but we can approximate. So let's draw up some axes now. And label our axes, y and x. We mark in our intercepts, neg 1, neg 2, and 4. Our y-intercept is neg 8, down here. And we know it's going to start top right to bottom left. So I would imagine the graph will look something like this, without knowing where the turning points are. Something like that. So there's our graph of that cubic. Okay, slightly harder one now to look at, and we've actually restricted where we're going to draw this graph. So what we've got here, we're going to draw the graph of y equals negative x cubed minus 5x between the x values of negative 2 and negative 1. So we only have to draw a short segment of this graph. Also have to state its domain and its range. Okay, and we need to keep revising those two terms. Alright, well, let's look at the x and y-intercept here. So if we look at the y-intercept, if we make x equals 0, okay, we're going to get y equals 0 as well. Okay, so the y-intercept is 0, 0. Now straight away, when we know that the y-intercept is 0, 0, we know that an x-intercept will be 0, 0. But let's just look at the x-intercept. If we make y equals 0, so x-intercept, make y equals 0. If we do that, we get 0 equals negative x cubed minus 5x. Now there's a common factor here of negative x, and we should always take out negative x instead of x. We get x squared plus 5. Now, I think we were all in class the other day when I said that any sort of x outside a bracket means that one of the solutions is 0. So x equals 0. What about this other bracket? What about if we try and make this equal to 0? Okay. We try and make the other bracket equal to 0 here. Like that. Then we get x squared equals negative 5. Now we can't get the square root of a negative number. Okay. So there's no other x-intercept. There's only one solution for the x-intercept, and that's x equals 0. And we already knew that was going to be one x-intercept because, as I said, if the y-intercept is 0, 0, so does the x-intercept. Stands to reason. Just draw something here. If it's going to pass through 0, 0 as a y-intercept, it's also an x-intercept. Okay, so because and I might just draw the equation up again. Whoops. Because this has only got one y-intercept, so we're looking at this graph. Let's draw a quick set of axes over here to look at. Now, because its only intercept is there, this will be a cubic in the form of having an inflection point like that, and it is in fact going to be that way, that is top left to bottom right. Why? Because there's a negative out the front there. Okay, there's a negative out the front of the x cubed, so it's actually going to be that shape there. So let's have a look now at the restrictions placed on this graph. Because you might have noticed a little thing here called X and the element sign there. What does that mean? Well, we're only going to draw this graph between x values of -2 and -1, not including -2 and -1. Remember the difference between those brackets and the curved brackets. That means you include the point. That means it's not including that point. Alright, so what we need to do in this case then is to find these 2 points, because what we're going to get is -2 comma something as one point and -1 comma something as the other point. What are those somethings? Well, we have to find the y value for each of those x's. So let's put -2 in to start with. Okay, so it's negative of -2 cubed minus 5 times -2 equals positive 8 plus 10, so that equals 18. So one point that we've got here is -2 comma 18. Okay, I'll just erase all this stuff here just for a moment, just to give us a bit more room on the other side. Now what about the other point? That covers -2. What about -1? Well, y will equal, putting -1 into the equation, y will equal negative of -1 cubed minus 5 times -1. Okay, and that's going to equal -1 plus 1 plus 5 equals 6. So our other point is -1 comma 6. So there's our 2 points there. Okay, and I'll just copy those over to the next slide, and we'll draw the graph. Alright, time to look at the graph now. Set up our axes. Alright, now we know the graph will, if let to go to the full extent, pass through the point 0, 0, through the origin. Okay? And we also have established that the graph will be that shape. Oops, not drawn very well. Will be that negative cubic shape like that. Okay? But it'll be interesting to see when we look at these points though, whether we have to go as far as that 0, 0 point. Because remember, we're not drawing the whole graph, we're only drawing it between x values -2 and -1. Okay, so let's look at these points. First of all, we've got -1, 6, so we'll put in -1 there. And we're not going to be able to draw this to scale very well, but anyway, let's put 6 about there. So that's -1, comma 6. The other point on the graph is -2, -2. The other point is -2, comma 18. Alright, now if we were to draw this whole graph, okay, it would be something like this. It would start sort of up here, and down here it would have a point of inflection at 0, 0, and away it would go again, something like that. Now we don't need that whole graph, okay, we only need the graph in between the points -2 and -1 on the x-axis. So I'm rubbing out all the other sections of the graph, here and here, because it's only that red section of the graph that we actually require to be drawn. Okay. Now it's important that we've got, because we had 2 curved brackets, that when we draw our graph, and I'll just try and get rid of those little crosses as well now, because they're getting in the way a bit. So it's important when we draw the graph that, and it's hard to do this on the iPad a little bit, so I'll do my best. But when we join those 2 points together, we've got open circles on both places. And the open circle means we're not including -2 and -1. okay, because we've got curved brackets back here in the question. Okay, so we go back to here. If we had square brackets, we would have closed-in circles. So domain and range. Okay, so we've talked before about the domain being the x values that the graph covers. Okay, so the domain here is going to be -2, -1. Now, if that looks familiar, that's how it was defined. Whoops, that's how it was defined in the question. Okay, the range is our y values. Okay, so we're looking here. Our lowest y value is 6. Our highest y value is 18. So our range is 6, 18. Alrighty, that's probably enough for the moment on cubics. What I'd like you to do now is have a go at, and once again you don't have to do all of them, okay, but exercise 1F in your textbook, and see how we go with that. That's all for now.